So today we are going to discussing about transistors. So a transistor consists of two p-n junctions formed by sandwiching either p-type or n-type semiconductor between a pair of opposite types. That is how it is constructed, or what is a transistor. So it is a device where two p-n junctions are combined together so that in result two p-n junctions are formed. So here you can see here you can see n-type. This here is a p-n junction and here is another p-n junction. So two p-n junctions are formed in effect. Okay, so two p-n junction diodes are joined back to back or sandwiching them together so that two p-n junctions are formed in result. So this is known as a transistor. So we can sandwich either p-type or n-type semiconductor between a pair of opposite types so that the transistor can be of two types accordingly, whether p-type or n-type semiconductor is sandwiching. So according to that, there are Npn transistor and Pnp transistor. An Npn transistor is composed of n-type semiconductors separated by a thin section of p-types as shown in figure Npn. So at the middle region is p region and both ends are n-type. That's why Npn. And p-type Pnp transistors, both the end regions are p-type and this is n-type. So Pnp. Or a Pnp transistor is formed by two p sections separated by a thin section of n-type as shown in figure. So this is about transistor in brief. It is invented in 1948 by J. Bardeen and W. H. Breton of Bell Telephone Laboratories, USA. Transistor has now become the heart of most electronic applications. So the heart means it is the main functioning, it is main part of the body, without which the body doesn't work. Likewise, transistors form the heart of electronics. Though transistor is only slightly more than 58 years old, yet it is fast replacing vacuum tubes in almost all applications. In this chapter, we shall focus our attention on the various aspects of transistors and their increasing applications in the fast developing electronics industry. So it shows the importance of transistor, why it is important in electronics. In each type of transistor, the following points may be noted. There are two p-n junctions. Therefore, a transistor may be regarded as a combination of two diodes connected back to back. So it's a combination of two p-n junctions. So we can say that it is combined with two diodes back to back. And second point is there are three terminals, one taken from each side of semiconductor. You can see here, you can take one terminal from this side and one terminal from this and one terminal from the middle part. So we can have three terminals from a transistor. The middle section is very thin layer. This is the most important factor in the function of a transistor. So you might have seen that this is Npn transistor, this is Pnp transistor, and you can see that the middle portion is thin layer compared to these two layers. Okay, this is very important factor in the function of a transistor. Okay, now we can have a look on how this name comes. Origin of the name transistor. When new devices are invented, scientists often try to devise a name that will appropriately describe the device. A transistor has two p-n junctions, as discussed later. One junction is forward biased and the other is reverse biased. The forward biased junction has a low resistance path, whereas a reverse biased junction has a high resistance path. The weak signal is introduced in the low resistance circuit and output is taken from the high resistance circuit. Therefore, a transistor transfers a signal from a low resistance to high resistance. The prefix trans means the signal transfer property of device, while resistor classifies it as a solid element in the same general family with resistors. So what's the meaning of transistor? So you can see that there are three regions here, and so three terminals appearing here. And what happens? There are two p-n junctions also. Here in the transistor, one junction is forward biased and the other junction is reverse biased. So when it is biased, the forward biased junction has low resistance path, whereas the reverse biased junction has high resistance path. So the signal is introduced in the low resistance circuit and the output is taken from the high resistance circuit. So the signal transfer from the low resistance to high resistance region. The prefix hence the prefix trans means signal transfer property of the device, while resistor means it classifies it as a solid element in the same general family with the resistors. Okay. Now naming the transistor terminal. A transistor, whether NPN or PNP, has three sections of doped semiconductors. If NPN, there are N type and P type and N type regions. Similarly, for PNP, P and P regions. The section on one side is the emitter and the section on the opposite side is the collector. The middle section is called the base and forms two junctions between the emitter and collector. Okay, so this transistor has three regions, and the region on one side is known as emitter and the other side is known as collector, and the middle region is called as base. Okay, so we can have a look on this emitter, collector and base part. The section on one side that supplies charge carriers, electrons or holes, is called emitter. The emitter is always forward biased with respect to base so that it can supply large number of majority carriers. In the figure 821, this is 83, this is 18, this is 811. The emitter of a PNP transistor is forward biased and the supplies Hall charges to its function with the base. Okay, so the emitter region is the lightly doped region. It supplies charges, whether either electrons or holes. If it is N type, electrons, and if it is P, the charge carriers will be. The next region is collector. So the section on the other side that collects the charges is called collector. So that is, if this is emitter, this is collector. Okay, and the collector is always reverse biased. This collector base junction is always reverse biased. Its function is to remove charges from its junction with the base. Okay, The collector p-type of Pnp transistor has reverse bias and receives Hall charges that flow in the output circuit. That is, this is the Pnp transistor, and in this is the PN junction, or this is the collector base region. So this is reverse biased, and it collects all the charges that the emitter emits. Okay. And the second is an Npn transistor. So this is the collector base region, this is the collector base junction, and which is also reverse biased. And the third region is base, which is the middle region. The middle section, which forms two PN junctions between the emitter and collector, is called the base. The base emitter junction is forward biased, allowing low resistance for the emitter circuit. The base collector junction is reverse biased and provides high resistance in the collector circuit. So it's quite obvious that this is forward bias, this region, and this region is reverse bias. So the resistance will be low in this path and it will be high in this path, because this is reverse bias. Reverse bias means there is no current flow. That means the resistance is very high. So resistance is very high in this region and resistance is very low for this region. So this is the base, the middle thin region. Okay. So this is about transistor, two types of transistor, Npn and Pnp in general, and some facts about the transistor. Before discussing transistor action, it is important that the reader may keep in mind the following facts about the transistor. So what are the facts regarding the transistor? The first one is the transistor has three regions, namely emitter, base, and collector. The base is much thinner than the emitter, while the collector is wider than both. However, for the sake of convenience, it is customary to show emitter and collector to be of equal in size. Okay, so this is the general picture. That is, this is emitter, base, collector. So generally, the collector region is very wide than the emitter region. You can notice the size difference of emitter and collector region, and the base is the very thin region. So in a transistor, the collector region is the wide region and the emitter is less wider than collector, and base is thin region. But usually we will picturize it as of same width, that is emitter and collector as of same width. That is the usual picturization, but actually this is the case. Okay, and the second point is the emitter is heavily doped so that it can inject a large number of charge carriers, electrons or holes, according to the type of transistors, into the base. The base is slightly doped and very thin. It passes most of the emitter injected charge carriers to the collector. The collector is moderately doped. So the particularity, the second one is the first one is about the width of this region, and the second one is about the doping. So usually the p-type emitter region is heavily doped so that it can have more charge carriers and it can emit more charge carriers to this collector, and the collector region is moderately doped region, and the base region is very lightly doped region. It's thin and it's very lightly doped. Okay, so the doping concentration is also differ as the area or width differ. And the third point, this transistor has two PN junction, that is, it is like two diodes. The junction between emitter base and base may be called emitter base diode or simply the emitter diode. The junction between the base and collector may be called collector base diode or simply collector diode. It's quite obvious, that is, there are two PN junctions when when a transistor is formed, here a PN junction and here a PN junction, and here also one PN junction here and another PN junction here. Okay, and usually the left side region is emitter and the right side region is collector, whatever be the type of the semiconductor, and the middle region is base, and the emitter on this PN junction region is known as emitter base junction or emitter base diode, and this is known as collector base diode or simply collector diode. Similarly, this emitter base diode is simply known as emitter diode. Okay, the emitter diode is always forward bias, whereas the collector diode is always reverse bias. The usual convention is this emitter base diode, this region is always forward biased and this region is collector base junction is always reverse biased when it is introduced in a circuit. This should be the usual convention. This emitter base junction always forward bias and collector base junction always reverse bias, whatever be the type of the semiconductor we are using. Okay, the resistance of emitter diode forward biased is very small as compared to collector diode. Therefore, forward bias applied to the emitter diode is generally very small, whereas reverse bias on the collector diode is much higher. We have seen before, that is about the resistance. Emitter base junction has low resistance and collector base junction has very high resistance. So for a low resistance region, a very small bias is needed, and for the collector base junction where to have very high resistance, a large bias is needed. Okay, so that's all the facts about transistor, some general facts about transistor. Okay, now we can discuss about the transistor action, how this transistor works or how this acts. So the emitter base junction of a transistor is forward biased, whereas the collector base junction is reverse biased, which we have seen now. If for a moment we ignore the presence of emitter base junction, then practically no current would flow in the collector circuit because of the reverse bias. However, if the emitter base junction is also present, then forward bias on it causes the emitter current to flow. It is seen that this emitter current almost entirely flows in the collector circuit. Therefore, the current in the collector circuit depends upon the emitter current. If the emitter current is 0, then the collector current is nearly 0. However, if the emitter current is 1 milliampere, then the collector current is also about 1 milliampere. This is precisely what happens in a transistor. We shall now discuss this transistor action for Npn and Pnp transistors. That is, we can see that we have seen that the emitter base junction of a transistor is always forward bias, and this collector base junction is reverse bias. So what happens? From this emitter diode, charge carriers flow to the collector. So the collector receives all the charge carriers which emitted by the emitter diode or emitter base junction. So if for a moment we suppose that this emitter base junction does not exist, that means no current will flow through this collector circuit, because the collector base junction is reverse biased, so there is no current flow. That means if the current in the emitter base junction is 0, then current in the collector is 0. If 0 charge carriers are there in the emitter base junction, there is no charge carriers in the collector region also. And for example, specifically we can say if 1 milliampere current is flowing through the emitter base junction, then nearly 1 milliampere current flow through the collector base junction. Okay, so we can discuss the working of sorry, let me check whether it is there in the syllabus or not. Okay, let's quickly go through the working of Npn and Pnp transistor. So working of Npn transistor. So figure 8.4 means this figure. Npn means Npn transistor. So this emitter base junction is forward bias, that is a negative terminal of the battery is connected to N region and positive to P region. So this is forward biased and this is reverse biased by connecting the positive terminal to the negative region. So this is the usual convention, and the forward bias causes the electrons in the n-type emitter to flow towards the base. This constitutes the current IA. As these electrons flow through the p-type base, they tend to combine with holes. As the base is slightly doped and very thin, therefore only a few electrons combine with holes to constitute base current IB. The remainder cross over into the collector region to constitute collector current IC. In this way, almost the entire emitter current flows in the collector circuit. It is clear that emitter current is the sum of the collector and base current. Okay, so what happens here is, when we are forward biasing the emitter base junction, this electrons will move towards this P region or towards the junction. So since the this is forward bias, since the base region is very thinly doped, only a few of the electron coming to this base region is combined with the holes in the P region, so that the combining the electrons in the hole, electrons with the hole in the P region means it likes moving the negative charge forward as it combines. So it constitutes the base current. So the charge carrier movement in the N region or emitter region constitutes the emitter current, and the combination of the electrons with the holes making the movement of electrons forward, and it constitutes the base current, and the remaining electrons is collected by the collector, and so it again flows out the circuit because this terminal is positively charged. So these electrons get attracted towards the outer circuit and it flow through this circuit. So it constitutes the collector current. Okay, so emitter, base and collector current. So we can see this, since a very small amount of electrons from the emitter is combined with the holes in the P region, almost all the electrons coming from the emitter is going to the collector region. So emitter current and collector current is almost the same. Okay, so this is the working principle of NPN transistor. Similarly, in the same manner we can explain the working of PNP transistor. That is, in the PNP transistor we can make the PN junction, emitter base junction, forward biased, and collector base junction reverse biased. Okay, so what happens is, when it is connected to the forward bias, this holes moving towards this junction, and when it combines with the holes with a small quantity of this combined with the electrons in the N region, which constitute the base current, and the rest of the almost 95% of the emitter charges coming from the emitter flows to the collector, and which constitute the collector current. So since this is the direction of the flow of holes, this is the direction of electrons, so the current will flow in this direction. Okay, so this is the working of PNP transistors, just similar to NPN transistor. So we can see that the collector current is almost equal to emitter current, because from the charge carriers from the emitter, only a small percent, about 5%, is combined with the base charge carriers or base charges. Okay, so this is about the working of transistor. Okay, now we can see the transistor symbols. So it is important to know the transistor symbol, because when you draw a circuit diagram, you have to include if you have to include a transistor, you have to picturize it as by its symbol. So we need to know this symbol. In the earlier diagram, the transistors have been shown in diagrammatic form. However, for the sake of convenience, transistors are represented in schematic diagram. So the symbols can be represented as like this. So this is for NPN and this is for PNP. You can see the emitter current flow direction is in the, since the negatively charged electrons are flowing in this direction, the current will flow, current direction is in this direction. Similarly, here the current direction is here. So the current direction from the emitter can be shown outward. So the usual symbol is with the air rounds a circle with a 3 terminal like V shape and a bar and a tail. This is the usual symbol, and this and this end. So this is the usual symbol. Here the left side terminal is emitter, the middle terminal is base, and this is collector. And you have to recognize or identify whether it is NPN or PNP transistor. It can be identified with this arrow mark. Okay, so here in the PNP transistors, the current is flowing out, so we can show an arrowhead outward from the emitter region. So this is NPN transistor. But in the case of PNP transistor, the holes move in this direction. So the direction of flow of positive charge is the direction of current, so it is inward. So in the emitter region, the current is in the inward direction, so we can show the arrow inward. So this is the symbol for PNP transistor. So this is how we symbolize or represents a transistor in a circuit. So this is the usual symbol, and this arrow, this direction of arrow is very important in order to recognize the current flow and hence the transistor type, whether it is NPN or PNP. So the emitter current and collector current direction is also shown here. The emitter current is outward and the collector current is inward in this direction. Similarly, since this emitter current is inward, the collector current is outward, and the base current here is inward, here it is outward. Okay, so this is the representation or symbol of a transistor. Okay, so this is all for today's class, and we will discuss the transistor configurations in the next class. Okay, thank you.